Research geologist at the National Laboratory of Materials and Structural Models of Costa Rica, and he will be talking to all of us about landslides today. So, Paulo, we can go ahead and start.
Hello, thank you, Ria. And first, I would like to thank Rutgers University and Rutgers Geology Museum for doing this kind of activities in these times. I know it's difficult to be inside in our house all the time, but with this kind of educational activities, time goes faster and we can learn something. So as Ria told you, I am going to talk about landslides. I'm going to explain you some basic stuff about landslides, some pictures and videos, and what I do related to landslides. And after that, we can go to the questions that have been asked or that you can ask. Something about me. I graduated from Rutgers University, where I did my PhD in 2012. After that, I came back to Costa Rica, and I have been working in the University of Costa Rica and the laboratory, doing mostly research on landslides and landslides on volcanoes. I did my PhD on volcanology at Rutgers, and then also I keep studying, but studying something different. I studied photography in the last 3 years, and I graduated just last year. So I encourage you to visit my Instagram account. That is this first one. And then this second account is the account for the Seismic and Volcanology Laboratory that is related to the University of Costa Rica, and where I post most of the pictures that I take when I go to volcanoes. I started working on landslides in 2009 while I was doing my PhD research. I was on Poás volcano the same day that an earthquake, a 6.2 earthquake happened. This earthquake was very shallow and created a lot of landslides around the volcano. And because of what I saw and the impact that created on me, I decided to include in my thesis a chapter just related to landslides. I was doing geochronology and geochemistry, but then I decided to include this topic or this chapter related to landslide because of the impact that this event or this earthquake caused in the surroundings of the volcano, especially related to erosion and to the infrastructure that is on the volcano. And I'm going to talk to you about that later during this. But let's go first to some basics. What is a landslide? A landslide is a term that can be used for two things. One is to describe the downslope movement of soil, rock, or organic materials under the effects of gravity. Also, friction has to do a lot in formation or in the creation of a landslide. And then the second use that we can give to this word is the landform that results from such a movement. So we also call a landslide this form that it is. And this landslide in this picture is really nice because it's also related to the impact that can have on our houses, our roads, our infrastructure. So here is a road that used to be here that was completely covered by the landslide, and also some houses in the down side of the land or where it happened. And this is what I'm studying right now in the civil engineering laboratory of Costa Rica, the impact on infrastructure, and especially on roads. There are many types of landslides. There are landslides that are related to faults, and we call them rock faults. And this is just when gravity helps these materials, these big materials like rocks, to fall. They can also bounce or they can also roll over. Then we have the slides, and the slides, there are two types. The one with a rotation movement, and it's like a spoon shape, or the landslides that are related to translational movement, just a slide going down. And then this is the third one, slide, with a translational movement. And then we have a fourth type that is related to flow. And we call these types of landslides debris flows. And this happen when we have rotational movement or translational movement, or also rock falls on the top of the mountain. And then the material goes into a drainage, and because of the water that is in that drainage, like a river or a stream, the materials will go down as a debris flow. When this happens on a volcano, we call these types of events lahars. And this is another aspect that I'm studying here in Costa Rica, because these types of landslides or debris flows, or as we call them in volcanoes, lahars, are very common in Costa Rica, with a high impact on infrastructure in the low areas and also in some of the areas on the slopes of the volcano. Okay, what are the triggers of landslides? Basically, there are three main triggers, at least here in Costa Rica. One, the first one that is very common and is the one that I'm showing you in this clip, it's because of rain. It rains a lot here in Costa Rica. It rains about 6 months. We are right now in the transition between dry season, where it doesn't rain at all, to rain season, where it rains a lot. It rains all the time, and when it rains, it can saturate the soil. When it saturates the soil, it means that the soil cannot contain more water, and then it gets heavy, and then the friction between the soil and the bedrock decrease, and then we have the slide. That's one of the triggers that we have here. The other one is earthquakes. We have a lot of earthquakes here in Costa Rica. We are on a subduction zone, and we have earthquakes related to subduction, and we also have earthquakes related to local fault. And these earthquakes can move the ground and shake the rocks, shake the soils, and create landslides. And then the last type, it's volcanic eruption. We also have volcanoes, like the one I showed you before, plus, or the one I'm going to talk to you about. And in some of these volcanoes, there are crater lakes. And when these volcanoes make an eruption, the lakes overflow and the water goes into the drainage and create lahars or debris. So that's the other trigger that we have. But why do we study landslides? Well, first, it's a serious geological hazard. It's very common in countries like Costa Rica, in tropical areas where it rains a lot, where the soil thickness is very high, where there are earthquakes and where there are volcanic eruptions. It's a very common and serious geological hazard. Then we also study landslides to understand the exposure. This means we study them to understand what are the areas that are more exposed to have these events. And we use this also for planning, because if we are going to build a project and it's on an area that is related to landslide, then we build that project with things that can or that can resist the effects of the landslide. Okay, what do we study about the landslide? Okay, here in the University of Costa Rica and the School of Geology and the Laboratory of Civil Engineering, we do many things. But first is we try to understand where and when will landslides occur. So we go to the field and we look for landslides, and we try to understand why they happen in that place. In order to that, we make correlations and we look for similar places to understand where will they. We also study how big will they be and how fast and how far will they move. This is in order to, I told you before, to plan for the structures that we build, like roads or geothermal plants or geoelectrical plants. All these like projects that are very expensive, we try to build them, we try to plan that in order to resist for landslides. Here's a picture of landslides that were triggered by an earthquake in Japan in 2018, very similar to what happened in Costa Rica when I was in the field. Okay, so what I do mostly is working on creating landslide maps. So I go to the field. I also use a drone to take aerial pictures, or I also use satellite images or just Google Earth to study an area and try to understand the relationship of landslides with that area. So we use maps as evaluation tools, and we use remote sensing in order to get that information. The first type of map that I do is a landslide inventory. So as I told you, I go to the field, or we take pictures or aerial photos, and we locate all the landslides. And in this map, all these white dots are landslides. And based on this, we start to get information that later on we are going to correlate with the slope, the type of rock, or many other factors that will tell us why there are so many landslides in this area, but there are no landslides in other areas. And using different factors like slope or amount of water in the ground or lithology, that is the type of rock or type of soil that we have in different areas, we create this second type of map, that it's a landslide susceptibility. And will tell us which areas are more susceptible to have land and which areas are not. And just based on this map, we will think or we will plan to have our projects in the areas that are less susceptible to have land. And then the third type of map, it's a landslide hazard map. And here we correlate and we use information from past events, present events, and future events of landslides. And we use this one actually for the planning. So we have a relative hazard scale where we have like zones with high hazard, medium, or low. And this is the third map that I work. I am going to explain you a bit more about the susceptibility map. That is the second type of map that I showed you before. And this is that it's related to areas that have the potential for landslide. We correlate factors. And in this case, I'm going to show you how we correlate. We use geographical information systems. So each pixel of this map has information related to the slope stiffness, or information related to the rock lithology, or the soil saturation. And then we multiply all the factors, all the information in each pixel of this map. And then we obtain intrinsic susceptibility. This means that it's a susceptibility just related to this factor. And then we need a trigger. And the trigger in this case is an earthquake. So we put the earthquake located where it happened or where it should happen with a magnitude and a depth. And then we create the susceptibility map for landslide for that specific earthquake. So we are modeling this earthquake that is 6.2, if I remember correctly. And then we see all the areas that are in red or orange are the ones with high susceptibility. And then we have these lines here that this is the Pan American road that goes from Alaska to South America. And it's a very important road. And that's the one we are trying to study. What's the susceptibility of that road to have land? And this is a project that I'm working on with our Rutgers students that are part of a project of the geology department. And this is the maps that they created using the model that I did for my PhD. Okay, so now we go and talk about Poás volcano. This is the one I talked to you about in the first slide of this presentation. So here we are in Costa Rica, in Central America. We are here in this small country, only 5 million people. And this triangle is where Poás volcano is located. And as I told you before, Poás has a crater lake. And sometimes when it doesn't rain or when it's very hot, the water evaporates and we only have some steam coming out on the emission. But when it rains, the water accumulates and creates this beautiful lake. When the eruption happens and when there is no lake, you can sometimes see some incandescence and hot material coming out. But when there is a lake and there is an eruption, the water, the ashes, the steam, everything goes up, and then when it comes down, it doesn't get exactly in the same place. It gets out of the crater, and then it will flow under the drainage systems and will go down slow and create debris flows in the heart. So first, I'm going to talk to you about the earthquake in 2009 and model. So here's the lake, the crater lake that I show you, and all these scars are landslides that were created by the earthquake in 2000. So I have been studying the landslides related to these volcanoes since 2009. So it's almost 11 years studying landslides. The triggers for these landslides have been the earthquake in 2009. There was an eruption in 2017, and excess of rain related to the rain season or to some tropical storms that we had in different years. So in these 11 years, 29 people have died because of the landslide. And then another important thing about Boas volcano is all these yellow dots in the map are structures related to hydroelectrical power plant. Here in this side of the volcano, we create about 8% of the total electricity that we use here. So there's a lot of equipment and machines and roads and infrastructure related to the generation of energy. And one of these plants, one of these electrical plants, was affected by one of the lahars that happened in 2009. So this is the electrical plant, and this is the water from a river flooding all the plant. And this is one of the turbines that was destroyed by this debris. Also, these were the pictures that I was able to take when I was getting out of the location of the earthquake, and some of the roads were completely destroyed by the landslide. But this was taken some days after helicopter, and you can see all the roads destroyed by the landslides that were created in 2009. So what I did was a susceptibility map correlating the lithology, the slope, the amount of water, and the trigger that in that case was the earth. And then we correlate our results with the actual location of each land. And based on that, we obtain a susceptibility map for Boas. And so here you can see that there are areas more susceptible. And then this is the case of the eruption in 2017, where we had a crater lake, and then a small magma dike came up and created the eruption. And then all the water from the lake went up. And when it came down, it went out of the crater and went down all this drainage and keep going down and down, affecting some of the infrastructure on the west side. Okay, but as I told you before, why do we care about that? I told you also that we have been using drones. So we care because by studying landslides, we can prevent the impact of these events. And now we are using technology like drones to go to danger areas or difficult areas that it's hard to get by walking or examples. So we use drones to fly around and to actually map and locate where the landslides are located, how big they are. We are creating digital elevation models, taking many pictures, creating these models with GIS programs. So this is the main reason that we care. We care because the impact that will have on the infrastructure. This is another type of maps that I have been working on, and it's we're modeling debris flows on another volcano. This is on Turrialba volcano, and we're modeling how the debris flows will go from the upper part of the volcano until the lower part, and it will get or hit or impact on bridges. This is one of the main roads that takes people and products from the central part of the country to the Caribbean side and where the ports are located. So this is a very important road, and we don't want these bridges to be hit by debris. So we have been modeling these events in order to see if there's potential for these events happening. And then for this presentation, I did a small research about where in the United States landslides and debris flows can happen. based on the different triggers. So based on excess of rain, I found out that in Washington State, Oregon, California, Colorado, Idaho, and other states, these types of landslides or events. Then we have landslides related to snow, and actually these are called avalanches. So we have this type of landslides in Colorado, Nevada, Utah, Wyoming, and Washington, as well as other mountains. And then related to volcanoes, earthquakes, hurricanes, and rain, we have the mountains, the Pacific Gulf range, some parts of Alaska, and of course Hawaii. Okay, and now I would like to show you one video that we took of this landslide here. This is an image from Google Earth. This is a new road that we are building here in Costa Rica. And this landslide occurred in 2017 after a tropical storm that went through the country, created a lot of rain, saturated the soil, and then triggered this land. So this is the image from Google Earth. I am this point. This is me and another pilot. This is where we are flying the drone, and we are going to see the video. This type of landslide in the video is one type of slump or rotational landslide. You can see here the upper part, the front. You can see some cracks in the middle of the landslide, and you can see the sides, left side and right side of the landslide. These are some of the cracks that were created by this movement. And then all the material got into a river that is actually dumped in the river, and it could produce some different events like the debris flow when this dam breaks. That the river is blocked by the landslide. You can see some of the accumulation of the water. At the end, because these materials were mostly soil and organic materials, this dam was breaking slowly, and it didn't create a debris or a big debris. But yeah, this was an impressive landslide related to rain. The old and upper part. This is where the road is. This road has not been completed yet, and actually this landslide corrected. Like company that is building the road is talking about moving the road, building it. So it's probably going to move it a kilometer. So you can see the cracks, and this is another typical feature of landslides. These small accumulations of water, also typical in big landslides. Okay. And I guess that's it. We would like to hear your questions. I have some of them.
We can't hear you right now, Paulo.
Can you hear me?
Yes, now we can.
Okay, sorry. Okay, you are. Okay, I have a question from Mary from Scotch Plains. Um, the question is, do all materials have the same angle before they slide, like rock, mud, sand? It depends. It depends on the area where you're located. Because with rocks, you can have slopes or angles very steep, sometimes like 90 degrees angles. And you can still have some landslides. Actually, in New Jersey, in the Palisades, you had some rock falls like 5 years ago, and this is a very vertical and very steep slope. Um, and then with sand and other materials, the slope, the angle of friction of that material will be less, but you can still have landslides. But then you need a trigger, that could be rain, an earthquake, or a movement. Yeah. Question. Well, I wanted to show you something before I go to the next question. It's really good, and it's on the link that you got for today's presentation. Let me- okay. Is this teaching activity from teaching engineering, and it's about landslides. It's really nice, and actually you can build a small model to create a landslide, and it could be related to the question that I just read about from Mary, where you can use different materials like rock, sand, or organic material, and putting some water in this slide, you will see the different landslides that you obtain, and can also build some houses and see the impact of the landslides on the house. So it's really nice. I encourage you to look at this teaching activity. And then the other thing that I wanted to show you is this place in Costa Rica. So these are two rivers. You can see one is blue and the other one is yellow. The one that is yellow, so here is the bridge, here is the river, the yellow and the blue. And I'm going to follow the yellow river to the top of the mountain, and we are going to get to this big landslide on Irasu volcano. This is another volcano. And then this landslide is moving very slowly, and it has been moving like this for some years now, and it's creating all the erosion that we are seeing down here. So all these yellow materials is coming of landslides. And this is related to another question that I saw there. That is the impact or the amount of erosion that is related to landslides. Can you hear me?
Yes, we can. Can you see the questions, Paulo?
Yes, now I can see it.
Okay.
Okay. Harold from Kentucky would like to know about landslides. Okay. This is a very interesting, a very good question. Actually, here in Costa Rica, we have some karst formation. Karst is the landforms related to limestone, or where rain dissolve the rock and create like to create caves or create dolomites or to create different landforms. And actually, yes, here in Costa Rica, some of the landslides that we have in the south part of the country where we don't have volcanoes are related to karst or to these areas where we have limes. And also, they can be triggered by earthquakes, or usually they are triggered by rain. And they are triggered by rain, as I told you before, also related to the formation of the karst. So by dissolving the rock, eventually we'll get to a point where there's no more rock or coal, and it will create probably a collapse or a landslide collapse. So all the dolomites and all the landforms, most of the landforms related to karst are actually part of landslides. Okay, question. Okay, there is a good question about how we alert people that a landslide will happen. And if there's an alert system to let people know and give them enough time to evacuate or to a safe place. The answer is yes. When, for example, when there is a big event coming, when there's a big event, I mean like a tropical storm or a hurricane. We had a hurricane in 2016 hitting us for the first time in history, and we knew it was coming. So we knew it was going to rain a lot, that it was going to rain a lot in the upper part of the mountain, and that it was very possible to have debris flows coming down the rivers. So we alert all the people living close to the mountain and close to the rivers down the mountains to evacuate those areas in order to prevent the impact of this land. Um, there are some countries like Japan where the maps that I show you, the maps, the susceptibility maps, they change based on the weather alert. So they know what's the saturation limit for a specific type of soil, and based on the amount of rain that they are registering, they know when it's possible or when there's no possibility to have a land. Based on this, they give early alarms and evacuate people. Uh, I have a really good question. What eruptions have you seen in person? I haven't seen eruptions on Plus volcano, that is the one I work for my PhD thesis, but I did saw some eruptions on Turrialba, that's another volcano. And these eruptions, you can actually see them from the city, that is like 15 miles away from the volcano, and this was were big eruptions. On this volcano, the one that we are studying, debris flows come down and hit the roads on the Caribbean side. Okay, I have a question here, really good, about the biggest landslide in the United States. It's a tricky question, but I'm going to say that at least recently, the biggest landslide in the United States has been related to Mount St. Helens eruption in 1980. In 1980, Mount St. Helens made a big eruption. But just before the eruption, there was a landslide that moved very similar to a rotational landslide. It was triggered by an earthquake, or there's also some discussion about what was first, the landslide or the earthquake. There was an earthquake related to this landslide, and then after that landslide occurred, the magma that was coming out was released because of the release of the pressure and created a blast. This is a direct eruption. And after that, a regular eruption, like going up, formed. But I will say that the biggest eruption, the biggest landslide in the United States recently has been that. Um, but if we go back into geological time, I'm sure there are bigger landslides. Okay, this is a good one. How many earthquakes have you felt and where? Okay, most of the earthquakes, I think all of the earthquakes that I have felt have been here in Costa Rica. And here, since we are in a subduction zone, we are part of the Pacific Ring of Fire, we have earthquakes related to subduction and also earthquakes related to local. So the ones related to local faults, the biggest ones can get to 6.2. It's like the one I show you that create all this time. And these ones occur at least every 6 to 7 years. They are very strong. You can feel it, and you can get scared, and something fall. Yeah, every 6 to 7 years. And then we have the subduction. Those are big. Those can get up to 7.6. And these ones occur at least every 10 years. The last one, the big last subduction earthquake occurred in 2012, and this was a 7.6. And the thing is that they occur in the ocean, pretty far from the city, so you can still feel them. And the difference from the local ones is that these ones are longer. So let's say a local one can like 8 seconds long or 10 seconds long. Instead, the subduction ones, you can feel them for like a minute or two and a half. But yes, and then we have like the small ones related to subduction or to local faults, and you can feel them at least once a month, 2 a month, and sometimes you feel them and okay, there's another. But when the big ones occur, yeah, you know. Okay, I have a really good question. Can landslides happen underwater? Yes, landslides can happen underwater, and when they happen underwater, and they can be triggered by an earthquake, because of the displacement or movement of material, they can also produce tsunamis. So there was an earthquake, a subduction earthquake, in the 80s in front of Costa Rica and Nicaragua. And this earthquake created underwater landslide. These underwater landslides create a tsunami that impacts Nicaragua. So yes, it's not common, but it could happen and it could trigger another event like tsunami. Okay, I have here a question. What kinds of lithologies are more susceptible to having landslides? Okay, for the experience or for what I have seen here in Costa Rica, it could be any lithology, but that has been weathered and turned into soil. And then that type of soil will have more susceptibility than strong rock or to slide. Then the other thing, at least here in the tropical country, is amount of weathering is related to amount of rain, change in temperature, and time. So the oldest rocks have more exposed to weathering and exposed to the elements, rain, change in temperature, humidity. So the older the rock, it will be more susceptible to landslides. Okay, let's go to another question. Okay, how far can the landslide travel? It depends. Some of the landslides, actually the ones like the slump type, the ones that have this shape, they don't go very far. They actually, the material stay there. Instead, the slides or the debris flow, they can travel hundreds of miles in sometimes, or tens of miles. It depends on the amount of water that we have in the river, and then also the slope where this event happens. But it depends. And then if you have also eruption related, like Helen, the material can travel also hundreds. Okay, I have a question that is, does the term landslides apply to lava flow? Actually, no. Actually, lava flows is a different process than a landslide, and also the form that is result from a landslide, as I told you in the presentation. But also, as I told you, landslides can be related to volcanoes and to volcano activity. So there is a relationship, but not in the term. I have another question. Where might the next giant landslide come from? Indonesia, Central America, the Alps? Okay, this is difficult to know. It could be anywhere, but also for what I know, and the landslide related to soil, um, it will be in areas where we have a very thick soil, a layer of soil, and this is tropical countries, countries that have a lot of rain, also where they have volcanoes or where they have earthquakes. There are the triggers of the land. So it could be in Japan, it could be in Taiwan, Indonesia, here in Central America. We don't know. Okay. Uh, okay. There's a question related to permafrost. Question is, do you get slides where there is permafrost? Okay, so permafrost is area located in the north part of where soil has been under low temperatures, and now because global warming is getting hotter and not frost anymore, so there are movements of ground in this area. Sometimes the ground can be flat, but because it's it's not frost anymore, we have some movements of materials and create landslides. Some of the shapes that I have seen in pictures or video are similar to the ones related to cars, related also to another question that we have here. But yes, the permafrost and and the global warming is also creating this type of event, these areas. In say that I don't think I have more questions.